Janet and Benzel. Welcome back to my channel. I am working on this LeetCode problem set today, and forever and always. I'm on question number 67, which is add binary, and I'm doing the solution here in Python. So I've given myself, and I usually don't start it while I'm reading through and trying to figure out a solution for this, but I've given myself about 10 minutes to get through a workaround in my head and also read through the question. So let's jump into this super quick question here. Given two binary strings, A and B, return their sum as a binary string. They then give you the examples and then the constraints. So I've been trying to think of the path of least resistance to solve this. And I think what I've decided on is I basically want to convert binary strings into integers, add them, and convert them back into a binary string. And the easiest way I can do that is with a simple line of code. So allow me to try this out. So we have the binary integer for A and the integer for B here. So this literally just converts the binary strings to integers, adds them, and converts them back. The only thing that we would need to do in order for this code to run, in theory, is return the result here, which would return the binary string without the 0b prefix. So I'd actually love to see if this works. Because when I did something similar before, I tried to use kind of a different method than this, which I did a similar problem to this where I initialized variables like as a list and tried to store the results and carry them, and then converted the input strings to lists so I could do more with that. So this solution seems like it could work. And then I also was like, when a previous solution I did, and I know a lot of people probably do this, they had to calculate the sum of the current bits and carry and do all that. And this seems just like a better way to do it. So let's give that a try. Okay. I'm thinking the runtime on this might not actually be that good. I mean, it says 27 milliseconds right now, but I'm thinking it could probably be lower. But you also can't beat like 2 lines of code, though. So I haven't submitted anything for this yet. Oh, why not? Why not? If it doesn't work, it doesn't work. My memory was terrible. That's probably the lowest memory I've ever had on any of these problems. And I've done over 100 of these now. Yeah, I only beat 9% of users who use Python for memory. But for runtime though, we got beating 93% of users who use Python. That's like one side. It's like that, that proves that a pendulum does swing both ways. So I guess if I were to redo this, which I probably will, the thing I was describing before, I would probably do that. I would make, yeah, okay, yeah, I would initialize a results list. Actually, you know what? We have time. We can do it. Why not? The timer's not going, but the recording is, so that's what matters. It wouldn't improve. The runtime might drop to like 70%, but at least the memory might be better. So let's initialize some variables here. Let's say we want the result here and the carry. And the reason I'm saying that is because we need to convert A and B into input strings so we can manipulate the whole set easier. So we're going to say list B, and then again up here we're going to say list A. So I want to make sure that the input length of these strings, because I do realize I just try to streamline that as easy as I could in 2 lines of code, but in a perfect world, we would make sure that the input strings have the same length by adding any leading zeros as necessary. So let's say while length A is less than length B, then A insert 0. And then I'm just gonna do some lazy girl programming. We're gonna take this and we're gonna do the same thing for a B. Ooh. We're gonna do the same thing for a B. And just change this to B, A, and B. Okay. So 2 binary strings, A and B, return their sum as a binary string. So we could iterate through the strings from right to left. So we should probably do that as a for loop. But that means we have to calculate the current bits and the carry, because we already know we're going to need a carry. And then we need to calculate the new carry. This actually might not work. But I've done something similar that does work. And so I'm trying to remember that pattern. Well, okay. You know what? We're going to say for I in range, let's say the length of A. That's going to be similar to the last problem I just did. I think it was 66. So this is iterating it from right to left, because I want to iterate it from right to left. I'm going to say bit sum is equal to integer A index plus int B I and plus the carry. Now let's calculate the carry by saying bit sum 2 and append the result bit to the left, because we're going from right to left, so we have to append that to the left. So we're going to say result insert string bit sum 2. So, but that leaves out that wouldn't necessarily finish all the carries, right? Because that's just inserting that to the left. So let's say, so if there's still a carry, then we add it to that leftmost bit kind of consistently. So if carry is greater than 0, the result insert 0 string carry. That way it just makes sure that it checks to make sure there's nothing left to carry. And then we need to convert it back to that string. So I guess I could do a return join result, because that would convert it back to a string, and it needs to be their sum as a binary string. We carry that over and add any leading zeros as needed. Actually, I would love to run this and see what we've got here. Because, yeah, see the runtime. What did I say? Last one was 27 milliseconds. This is 30. But you know what? I would love to see how this compares to my initial one. So let's see if it actually works. Bro. Okay, so 7 minutes to do this solution, but my memory was so much better of like beating 63% of users with Python. But my runtime, I thought it was gonna like drop to 70%. Nah, bruh, this hit 36. Man, if I felt like doing one more solution for this, I would, but I think 2 is enough for ya girl. Ugh. Such a sad day. Like, look at the difference. Like, this is how my brain wanted to think about this. This was like giving my brain too much time to think about it. And it was just, I mean, it's a little bit more middle of the road, but I feel like this one to me was overall a better, like more effective solution. So you win some, you lose some. I'm gonna leave both of these in my GitHub repo. I'll just have it as, this is 67. I'll have it as 67A and 67B. You guys are more than welcome to fork and clone both of these. Make both of them better. Make both of them worse. Have some fun. Learn something new. Try 80 different solutions and see which one works best for you. Because I know that made me want to cry. It didn't. I'm just being dramatic. But digressing, it definitely... when it just goes to show if you overthink something, sometimes it's not always the best solution, but it does make it a little bit more neutral. So thank you guys so much for watching. I will see you in the next video. Goodbye.